2 videos ago, we saw that margins never determine a joint table, except in one special case, and it is the most important special case in probability. In this video, we define independence for random variables, the joint PMF factoring into its marginals, watch expectations of products split cleanly in two, and collect the payoff that powers the rest of this course. For independent variables, the variance of a sum is the sum of the variances. Random variables x and y are independent when the joint mass at every pair is the product of the marginal masses. One equation checked at every cell of the table, joint equals marginal times marginal. We have already met an independent pair without naming it. Draw 2 balls with replacement, and the all-ninths table is exactly 1/3 times 1/3 in every cell. Sweep the margins across the table, and they rebuild it perfectly. The without replacement table fails immediately. A product of positive margins can never manufacture the zeros on its diagonal. And the connection to Chapter 4 is exact. X and Y are independent precisely when the events x equals x and y equals y are independent for every single pair. Independence of variables is independence of events, enforced across the whole table at once. Factored joints make expectations easy. Take the expectation of the product x times y, a double sum against the joint. Substitute the factorization and the double sum separates x terms with the marginal of x, y terms with the marginal of y. The expectation of a product of independent variables is the product of the expectations. Roll the 2 dice again. Each has mean 3.5. The rolls are independent, so the expected product is 3.5 squared, 12.25. No table required. And nothing was special about the identity function. For independent x and y, the expectation of g of x times h of y splits the same way for any functions g and h. Keep that one. It does quiet work everywhere. Now the identity this chapter has been building toward. Means of sums always add. That was linearity. No assumptions asked. What about variances? Expand the variance of x plus y around its mean, and the square produces 3 pieces. The variance of x, the variance of y, and twice a cross term, the expectation of the 2 deviations multiplied together. That cross term measures how the variables move together. It will later earn the name covariance. But let x and y be independent. The cross term becomes an expectation of a product of independent quantities. So it factors by the rule we just proved. And each factor is a deviation from its own mean, whose expectation is 0. 0 times 0, the cross term vanishes. For independent random variables, the variance of the sum is the sum of the variances. Hold the contrast means add always. Variances add under independence. That asymmetry is why independent noise averages out, and it is the engine inside every limit theorem still to come. 2 small pieces complete the picture. A random variable can be independent of an event. Conditioning on S then changes nothing. The sliced PMF equals the marginal, every bar untouched. And the workhorse configuration of all of probability, draws that are independent and identically distributed, IID. 1 PMF, copied across n draws with the joint factoring into n identical terms. Every sample, every repeated experiment, many data set we model from here on starts with those 3 letters. The key idea of this video: independence factors the joint into its marginals, so products of expectations split and variances of sums add.